So what's it look like?
It's sine of negative 7 pi over 12.
Oh,
I'm just trying to get more comfortable with it.
yeah.
Yeah.
I'm just having a bad day. Oh, shit. I was like, come here and sleep, or do homework and get caught up at lunch.
Oh yeah, I have that book
So we can be more
actually.
productive.
Do you have the 8th edition now? No, you just have the 8th edition.
actually, let me see, good. If you did miss yesterday, I have not brought with me, there's a very important handout
Put it together.
that I gave out yesterday. I gave that out yesterday, the one that's all gray. Yes, cool. You desperately want to either email me or see me, I can send it to you. It delineates the things you have to memorize for trig identities versus the things you don't. So yesterday we proved this. Can somebody help me out? What's sine? Let's use A plus B instead of alpha and beta. What's sine of A plus B?
Sine A, cosine A,
I like it.
sine B plus or times cosine A.
Whatever you want to do, right? It doesn't matter which one you put first.
I like his way. It actually makes sense.
What way did that?
Oh, keep them the same, just changing the alpha.
Okay,
Right.
that's the way I do it too. Makes more sense. It is. And then cosine A plus B.
Is cosine
Cosine
A?
A, cosine B, minus
Minus
Sine A.
sine A, sine B. Alright. And the minus, if this is minus, this would be minus. If this was minus,
This would
this
be
would be plus. Right? So the basic, quick way to remember this is cosine is a asshole. Asshole. Right? You gotta love that. It doesn't happen very often in mathematics, so that's the way you remember something. Cosine says, alright, me first, screw you plus, I'm gonna make it minus, or screw you minus, I'm gonna make it plus, and then you come last. And sine is all, oh, you're plus, I'll keep you a plus, and now we'll both go, that's just the way I remember. I don't know if it's true.
I think trigonometry uses a lot of ass factors.
Yeah, however you want to look at
Ass
it.
triangles,
Whatever gets you
ass
through.
cosine.
I love that.
It talks about asymptotes too.
I was waiting for that. Alright. So this one asks you to use either an addition and subtraction formula to figure out what this value is. And of course, we don't know any twelfths of things.
The way I did it was, can I bring the negative out since sine is always negative?
Yeah, so one way to do this is to realize that sine has odd symmetry, right?
Yeah.
Which means if you put a negative value in, you can bring a negative out. You could do that, or not. Doesn't really matter. All right, so that's available to you if you want to do it. Now, if you do that, can you figure out two things that make 7 pi over 12?
3 twelfths and 4 twelfths.
Yeah.
Yeah, there you go. So if you brought the negative out, is everybody cool with this first step here? Ever see that? And you don't have to do that, but that's not a bad idea. Put the negative out of the way. And then 7 pi over 12. You want to break it down now. You know values that are over, for example, what? Instead of not over 12, we know over 6. We know over 3, 4, 2, right? So we want to try to break it down. So if you have no idea, you could try to say, okay, 6 pi over 12 would be pi over 2. But then it leaves pi over 12. And I just figured out, I don't know pi over 12, shit. So then you start to think, okay, 4 pi over 12 would be pi over 3, and 3 pi over 12 is pi over 4. So then I know those values. Do you guys see how to start attacking this thing? You start to try to strip it down into something you know and see what the other piece is, and hope to God it's something else you know.
Right. This would be addition, yeah.
Yeah, so this is definitely the addition. Especially now we got the negative out of the way. So I got negative, so I can rewrite this as sine 3 pi over 12, which is pi over 4. 4 pi over 12, which is pi over 3. And then I can use that formula there to break it down to sines and cosines of things that I know. You guys with me? Okay. So those of you who chose to answer that, you're with me. Okay, good. And so you just put a negative on the very outside. So you get sine, just doing the sine, dude, sine pi over 4, cosine pi over 3, plus, because become that. Sine pi over 3, cosine pi over 4. And now you know these values. Do not give me a decimal answer. That's bullshit. Right, I could have gotten that from the beginning. Well, the whole point of this is to give me an exact answer because it's based on things you know.
Yeah.
How we doing?
Yeah.
Okay. So anything else from homework? Yeah.
80 on 7.1.
Oh, cool. Okay. So we'll look at this one, and then I got some specific ones I want to look at because there are certain generalizations you can kind of tease out of these identities. So I told you last time we had a whole little discussion. Well, it was mostly me just jawing off, but about identities and how you have to feel free to make mistakes and go back and try something else out. You got to know these identities. So number 80, right? Yeah. Oh yeah. So some of these are pretty straightforward as far as what to try. Just that thing upside down equals
4 tangent x,
thanks.
secant x,
So number 80, section
7-1.
7.1. This one here, right? Okay. So is there anything really obvious when you compare the forms of the two sides? It just tells you what you got to do.
Just the common denominators.
Yeah, I've got two terms here. How many terms I got over there? One. Good. There's no pluses and minuses. I got one term over there. So the quickest way to make two terms become one is to put them together. I need LCD to do that. Cool.
I got that part, but then I didn't come up with it.
All right, let's see. Maybe it's a book typo. So what's this dude need?
1 plus sin x.
1 plus sine x. You see what's going to happen on the bottom?
1 minus sin x.
Yeah, he needs 1 minus sine x. Do I have to do anything over there?
No.
Could I do anything over there? By itself, but I can't do something to both sides, right? Because that would assume it was true. That's what we're trying to prove. We're trying to prove it's true. So the bottom, what's really kind of nice about the bottom?
It's a difference of squares.
Yeah, difference of squares kind of thing, right? It's a conjugate, which is the same, I like it, so same thing. So I get 1 minus sine squared, which is
Cosine.
cosine squared. Good, I want that to become more immediate. 1 minus sine squared is cosine squared, because those two together make 1. Thanks for that. Alright, so then on the bottom of this, is everybody cool with that?
Yes.
This would be 1 minus sine squared, which is cosine squared.
Yep.
And on top I'll get, some stuff that's going to cancel, thankfully.
1 plus.
I get 1 plus
2 sine x
2 sine x
Plus sin squared.
plus sine squared minus
1. That's 1.
1.
minus 2 sine
Yeah, minus is plus 2 sine x.
Minus sin squared x.
Yeah, and then it's a plus and then minus sine squared x. Good. So that's just foiling and being careful with the negative there, right? Is that cool?
Yeah.
So where do you go from there? What happens?
Start canceling.
Common denominator, or get likes together.
Yeah. So what goes away?
Sine.
One's cancel.
One's cancel.
Sin squared's cancel.
Sine squared's cancel.
So there's just 4 sin x.
4 sine x, which looks good because I got my 4.
Yeah.
See, this is also partially what confused me too, is this part, because there's no additional for the secant. I mean, you get the cosine that's extra cool, but unless you're just assuming that there's still that.
Now, if you wanted to, right here, you can start working with the other side. But you should be able to see this.
Separate it out.
Sine over cosine is
Right.
1 over cosine is
Secant.
done.
It's just what got me is
Oh, I
there's
see.
no actual 1 there, so it's like, what the fuck? I mean,
What 1? What are you talking about? What are you talking about? Say
I
again?
mean, you got the actual cosine, but there's no 1.
There's always a 1 there. There's always a 1 there. We just don't write the damn thing. We don't want to waste time. We just know it's there, right?
It got me.
See, so that's how you kind of splay that out. Right?
Yes.
Now, if you're not comfortable with that, become so. Or, just start with this guy. What's tangent?
Sin over cosine.
Sine over cosine. Why is this sink, Jeff? Sine over cosine And then secant is 1 over cosine, and then you get 4 sine over cosine squared, and you've either proven it here, or you've proven it here. You've got to make the connection between the two sides somewhere. How we doing? That one was, now let that kind of problem be straightforward. It had 2 fractions on one side, and then a single term on the other. That's telling you, hey, put these together. And then just, hope something, something's going to happen. There's going to be identities. Things are going to cancel. It has to, because every single one of these problems I give you is true. So that's got to become that. So don't think any of them are going to be, well, this one doesn't work. No, don't write that. They all do. Did you ever?
Yeah, I was just trying to cosine squared. You're going to get split by cosine plus cosine.
Well, it's cosine, cosine.
Yeah, it's cosine
Oh,
squared.
you're cool done?
Yeah, I'm just trying to get the idea of splitting them.
Oh, yeah. So it's the exact same idea as 4 over x is, 4 times 1 over x. Right? And I've just used that several times over. Yeah, and again, if that's not the most comfortable thing to do, you just, at this point, you go over there and you start playing with that side. So you need a connection. You need both sides to be equal. You need to work with one side and make it look like the other side, or you can work with both and make them look like each other. As long as you don't multiply both sides or add both sides or anything, that's assuming the equality is true, which is neat. Prove it's true. Well, assuming it's true, no, I'm done. I assume it's true. No, that's not good. All right. So any other specific questions on the homework? Or general, or whatever? Okay. All right. So I want to do several types with you. I had some picked, and of course I don't think I brought that paper. Ah, there you go. Have some crisp page, Jeff. So on page 498, the page we're on, section 7.1. Let's take a look at these here. Oh, this is the old one. Look at number 37. Let me write it up here. $4.98. I'm waiting for somebody to write, well, this is obvious. Then go to the next one. It's obvious to the most casual observer. So somebody have a suggestion on something to do here.
Break it down into sine and cosine.
That was on the homework.
No, it wasn't.
It was on my homework.
Okay, cool.
What was this page 499?
All right, so you can break it down to sine and cosine. Right? So this will be sine over cosine plus
Cosine over sine.
cosine over sine. And now it looks a lot like the last problem we did, believe it or not, because the last problem was 2 fractions equals the same thing, right? Common denominator, right? So what's this guy needs
Sine.
sine. This guy needs cosine. Of course, sine squared plus cosine squared is
No, it's 1.
1. And what's 1 over sine theta? Cosecant. And what's 1 over cosine? Secant. Are these equal?
Yes.
Yeah. Say again, sir?
He was joking. He was joking.
Oh, okay. Is that all right? So, I mean, what told you from the beginning to try to do that? I mean, why would you start with this side necessarily?
The other side's simpler than you mean.
Yeah, the other side's simpler. So this has got an actual addition that needs to be done. So it's not a bad idea to start with this side, right?
Yeah. In the math lab, they told me to start with the most complex one.
Exactly. So that side was simpler. So we start with that side.
All right.
That's all right. Let me show you something. Let me show you something that's a little bit freaky, but maybe some of you guys will like it. This is the way I kind of attacked a lot of these. This problem I probably would do like that, but I just want to show you it works almost no matter what. And if you don't like this at all, okay, it's just a suggestion, it's just a possibility. I know some of you guys are not going to like this, but that's all right. I love this way. This is not always the best way. This is not the best way in a specific problem, but I just want to show you it works no matter what. So we're at secant again. Remind me, secant is basically 1 over cosine.
1 over cosine.
And if let's see what you guys cool. If I know there's a secant times cosecant there, right?
Yeah.
So one thing you could try, especially when you're not sure what else to try, is to force a part of the side you're working on to look like the other side. And then what's left has to somehow become what should be there. So what I mean is this. If I took a secant theta out, let me just show this to you. What the hell? Maybe a couple of you guys will like this. None of you have to like this. None of you ever have to do this. Oh, what's on the bottom of tangent?
Cosine.
Cosine. So when I take a secant out, that's the 1 over cosine coming out, so I'm
So
left
one
with
sine.
sine. Isn't tangent sine over cosine?
Okay.
Now cotangent kind of sucks. Yeah, so what I'm going to get left with, if I take the over cosine out, I'm going to be left with cosine squared over sine. Because there's already a cosine over sine, so if I take a cosine out, I'm dividing, take a 1 over cosine out, right? I'm dividing by that, so I get cosine squared. Now, again, let me just do this very quickly, because I know most of you won't like this. What does that inside have to become?
Secant.
Cosecant.
Cosecant. It's got to become cosecant, you know it. So then you can just attack that inside and make it look like cosecant. Now, in this specific problem, that's kind of not a great idea. But you could do this kind of thing every time, and it's got to work. You make a part of your thing look like what it's supposed to, and the rest of it has got to become that. How do I know that's true? Because this equality is true. I'm just trying to prove it, but they already told me it's true. So here I would just get like denominators like we just did. They get sine squared over sine plus they get 1 over sine, which is cosecant.
So bad.
It's not so bad, but it's a little weird. It's a little weird. Maybe a couple of you guys kind of get what I'm trying to say. I'll show you this kind of thing every now and again, just to see if you guys
I don't see how that really makes sense.
buy into it. That's cool. Then don't do it. Don't ever do it. You never have to do that. Yes?
Just because, for me, can you do the cosine squared? It's because you took the cosine.
So if I,
Just
so
write it.
let me rewrite this. Sine theta over cosine theta plus cosine theta over sine theta. So if I try to take out a 1 over cosine theta, that obviously comes out.
Yeah.
So what happened to this?
Well, that becomes
Did it get,
sine.
it kind of got bigger in a way, right? Don't argue with me about what cosine is. It actually gets one, but it's now a sine because it got cosine theta times bigger, didn't it? Because I took out a 1 over cosine. So what's going to happen to the other guy? Same damn thing, because I'm doing the same damn thing. It's going to get cosine of theta bigger because I'm taking a 1 over cosine out.
Yes.
Is
Cool.
that kind of like the other ones when you try to pull something out and there's not enough, you divide by it? Okay, got it.
Yes, sort of, yes.
It's because when you divide, you multiply by the reciprocal, yeah.
You multiply by the reciprocal when you divide.
Yeah.
Exactly. So when I take something out, I'm dividing by it, so I multiply the inside by cosine.
Yeah.
Okay, enough of that.
That's all.
That makes sense.
Good, I like it. And very often, what's left is easier to look at. What's left here is kind of easier to look at. On this problem, I probably wouldn't have done that because this problem was just so easy to tell what to do. I'm not saying it's easy to do it, but I knew I had to add these things together to get that. And the way to add these things together is write them as fractions and get like denominators. Go from there. Now, look at let's see what I got next here. 53.
What page is all this?
This is section 7.1.
498.
$53.
1 minus cosine alpha over sine alpha equals sine alpha over 1 plus cosine alpha.
Now this is actually sort of a merging of what I just said. The process you use, who has an idea what to do here? I mean, this is really, really looking weird. It's totally not obvious that this is true.
Common
Well, one side, You can the right side you can multiply by the reciprocal, so that you can get
Multiply
more
by,
conjugate. Sorry.
okay.
Um,
Sure, you can do that to either side. So if you want to do this side, let's do it. And look how that matches up with the way I was just talking about. What's supposed to be up here? 1 minus cosine. Okay, well let me put a 1 minus cosine up there. Which means I got to put a 1 minus cosine down there. So you can look at it this way, or you can just look at it, well, let me multiply by the conjugate. And another reason you might think that is because when you multiply by the conjugate, you end up with squared stuff. And what's nice about squared stuff in trig? Be more specific. There are many identities that have squares in them that relate to trig functions with each other, right?
Yeah.
Sine squared, cosine squared, tangent squared 1, blah, blah, blah. So this happens a lot where you multiply by the conjugate because you create an identity in the process. So what does this become on the next step? This is
sine minus sine cosine.
yeah. Now notice this on the top. I'm not going to multiply that through. Now why wouldn't I multiply that through?
Because you're going to pull it out eventually anyway.
Because I want that to be there. So what do I know is going to happen to this guy?
It's gonna cancel.
He's got to cancel. And of course, what do I get on the bottom?
1 minus cosine squared.
Yeah, 1 minus cosine squared alpha, which is
sine.
Sine squared. Cancel.
yeah, and then you cancel that guy and you get
1 minus.
that. So since I've proven this equality now, right? And again, this happens a lot where you see this type of thing. They both only have one fraction, so there's no combining you can do. But you can't apply a conjugate. I could have multiplied this side by 1 plus cosine on the top. That would be related to rationalizing the numerator, which sometimes you have to do. But it's the same stupid idea. I'll multiply by 1 plus cosine because I want a 1 plus cosine on the bottom. All right. I just kind of like to look at it that way at the same time.
The reason why I did it that way is because, I mean, if you had to separate it, you can do the 1 over sine x on that side minus cosine over sine, which could also then become, your cosecant, I think, and then
I like it.
your cotangent. But on that side, you can't do it by itself. So
you left it open that you could play with this thing a little bit if that thing came out to look like a certain way. Okay, I like it. I like it. So real quick, since that original equality is true, what does this equal?
Oh, it's a secant and cotangent.
No, don't overthink it.
Sine alpha over 1.
Yeah, equals sine alpha over 1 minus cosine alpha. Since this equality is true, I can now do stuff like that because I've proven the equality to be true. So I can get some alternate identity forms from it, right? So I want you to realize, look at this homework and imagine what the authors could have done. And then you have another pre-calc book where they have entirely different examples. How many identities actually exist?
Lots.
A lot, right? How many do we have to memorize? How many are important, really? I can build all these other ones off the basic building blocks on that green sheet.
Great.
Gray sheet, sorry. It's green for you. Yeah. Somehow it's related to the different versions of them. Man, I'm geeky. Alright, so let's see, that's 53. Let's try 66. Here, you guys try this one. This is gross.
That's it.
Could you do this one that way that you were talking about earlier?
What's that? Yeah, you could. Totally. It's really weird. See how cosecant is 1 over
Yeah,
Cotangents
yeah,
over sine, right?
that's true.
There's a really long ass way to do this problem. Let me just stop anybody in their tracks who are trying to put these two together. What's on the bottom of this guy?
Sine.
Sine. So like if you try to put these two together, you have to give both of them something, and that might lead somewhere. It's not the first thing I thought, but maybe that'll lead somewhere nice. Well, it has to, because I know it works. But there's a much quicker way to do this problem. It's based off of something we just recently did.
Oh, wow.
Is that legal?
What's up? I don't know.
I think so.
Yeah, that's what I was saying.
Yeah,
Well, wait. What are you trying to do, sorry? You taking a sign out?
Mm-hmm. Am I doing that wrong?
Yeah, because then there would be sine squared down there, because you're dividing by sine if you take it out. Yeah. All right, let's see.
Oop, oop.
Well, I got one over side. A and not cosecant.
Yeah, exactly. Yeah, exactly. So you, yeah, exactly. That's the way to do it. So there's more than one way to do this, but there's definitely a quicker way to do this. One of my teachers used to give elegance points. And he says, there's always the most elegant. I was always a guy that's like, just get it done, get it done. He's like, it's very elegant. And he gave elegance points, and I got very few of those. Elegance points. And then another teacher graded us on grammar and math. I loved it. It was awesome. But the quicker way to do this is to actually attack this the same way we attacked this guy. So multiply top and bottom by. That's just one way, right? There are other ways. Always, there's more than one way. So on the top, let's see, on the bottom I get 1 minus cosine squared, which is
Sine squared.
sine squared. So I want to keep these apart because, yeah. And of course, cotangent is, and so instead of from the beginning forcing the bottoms to be the same, if you simplify this piece, the bottoms become the same, yeah. And of course, 1 plus cosine minus cosine
Is 1 over sine.
is 1. And 1 over sine is cosecant. Done. Kick ass. Good. I don't know if I want to show you my way.
Yeah,
Yeah? Okay.
just because I was trying to do it.
How'd you do it, Chris?
Well, no, I'm just trying to see how that works out right there. From the jump from the 1 plus cosine.
So this bottom
No, not there.
becomes...
Farther down. Next step. That.
So that sine cancels, and you have 1 sine left on the bottom, because you had 2 down there before. 1 plus cosine minus cosine. Cosine's canceled.
Okay.
You're left with 1 now, because now they have the same denominator. Yeah. So real quick. I'm just gonna barrel through this. I'll show you how it looks that way I showed you earlier. Just to show you.
Yeah. It's kind of interesting.
So first of all, it's done.
Say again? No. Yeah, that's a good idea. So if I want this to look like cosecant, what I would do is I would take a cosecant out. And of course cosecant is 1 over sine. So this becomes sine squared. Good, based off that earlier conversation.
And that one
Oh,
becomes
why did
And this
I
one
do
becomes,
that? I'm dumb.
cosine alpha over 1.
Cosine, yeah.
I left it as a fraction just because it was easier.
Yeah. Again, this is not always going to be the best thing. I normally would use this if I can't figure out a good way to start. I force a part of what I'm working on to look like what it's supposed to look like, and then I can see if then anything left is easier to work with, and then I'll go that way. So what's left here isn't necessarily easier to work with, but it's not horrible, because all he needs
Is
It's
a
one
1 minus
minus
is
cosine.
that. And I know what's going to happen to this whole thing. What's got to happen to it?
It's gonna be 1.
It's got to become 1,
Yeah.
because I know my answer is supposed to be cosecant. So I get sine squared a minus,
Cosine.
this guy needs, multiply it by 1 minus cosine, it'll be
Cosine.
minus cosine plus
Cosine squared.
cosine squared.
Oh, bam.
So it becomes 1.
Yeah, that's
1.
1 minus cosine over 1 minus cosine is 1. Done. Yeah. So it was a little bit quicker. Maybe we were about the same length. I can't remember what my teachers thought of that, because they, you can teach. When you see this, you think conjugate, or when you see two fractions, that is right. You first get those together. When you see these types of things, you do it. But what I always did was, when I wasn't really sure, I just made a part of what I was working on look like it was supposed to, and then I could work on the rest. And nobody ever taught me that, right? So that's what I like to teach when I do this. Okay, so the next one. 84. Ooh, yeah, that looks yummy.
Did you say 84?
84.
Oh, hey, this is. What if anyone's doing it my way? Mm-hmm.
So, what are you guys doing?
Not your way.
I figure that. So be a little more specific. I did it not your way. I can guess what
I
you're doing.
separated them out. Just.
I made it.
You can't separate anything here because there's more than one term. Did you mean you put
No.
cotangent over, or how do you mean?
I don't know. Don't ask me.
Okay, I'll stop.
I did.
Most of it.
I just.
Yeah. So I think the most immediate thing most of us would do is just multiply by the conjugate, based on what I just said. I mean, there's definitely an identity with cotangent squared in it. So if you multiply this thing by its conjugate, yeah. Let's see. So cotangent x
Plus 1.
plus 1. To be honest, it doesn't really even matter which one you do, the top or the bottom. So on top you get squared plus cotangent plus cotangent plus 1. In fact, what I even, yeah, sure. And on the bottom I get cotangent squared x
Minus 1.
1. And what's your idea? You know, s sine squared plus cosine squared equals 1. And real quick, I meant to say this earlier. Do you see what I just did?
Yeah.
This is acceptable. This is kind of like just getting to the heart of an identity. But never write something like that unless you really, really mean it. What does that mean? What's the operation?
Sine x. Sine of cosine.
Wait.
Sine of cosine x.
Yes. There's no product here. This is not sine times cosine of x. Because sine by itself doesn't mean anything. So when you write this, you really mean this. You really mean sine of cosine x. So this is one of the most simple mistakes that I see people make. And on one level, it's just, somebody can argue that it's a typo or whatever, but it could screw you up later down. If it's supposed to be sine x by itself, its own thing, sine x times cosine x, you better write that. Otherwise, later you might freak yourself out. Okay, so sine by itself doesn't mean anything, but this is acceptable just to get to the heart of something real quick, the identities. So if I divide it by sine squared, I get 1 plus,
Cosine.
Cosine.
no, this is, well, be careful. If I divide by sine squared, cosine squared divided by sine
Okay, 1
squared
plus
is,
tan.
Cotangent.
and then you get away from there, because there's no, they're both c's, too bad for us. And that was 1 over sine squared?
Cosecant.
And can I use that somewhere?
Sure.
Right there.
On top.
Yeah, you can use that on top. Now, do you see this going towards
No.
what it's supposed to look like? So you can maybe try a couple more steps and see if it's going to go somewhere. So cotangent squared plus 1 is secant squared, cosecant squared. But I mean, I don't see that really going where I want it to go. I don't know if anybody went further than that on this problem. All right, anybody try a different tack?
I don't know if I'm right, but I just multiplied the top and bottom by cotangent minus 1. Can I do that?
Sure, you can. Yeah, you can attack. And this was kind of clearing the bottom, but you can clear the top instead.
Yeah.
And so we should end up
It
with
really helped me at all.
roughly the reverse of this, almost, right? Yeah. Okay. Anybody else have a suggestion?
Maybe we could work with the right side.
Yeah, excellent. So, I mean, this type of thing is going to happen to you. You got to let this happen and not be freaked out when this happens. You try something, it doesn't work. You go back. You try the other side. But what do you think might happen with the other side?
It works.
Something very similar is probably going to happen. But let's see, did anybody try it out? Did anybody attack this side with a conjugate? Anybody? Nobody? Everybody went for this? Second?
No, you hard gets.
You'll get secant. Yeah, you'll get something, I would bet you get something very similar to what we just got. So guess what? One reason why I picked this problem is because my way works. That almost don't way works really well. That actually would work eventually, but my God, it would be like 15 lines of stuff. So what I would do, and what you should do in this problem, is multiply by, it doesn't really matter, I'm going to multiply by 1 minus tangent x. Now why would I do that? Because I know I want that on the bottom. Right? So I'm going to leave him alone. I'm not going to multiply that through because I want him there. Maybe. So on the top, what's really nice with tangent and cotangent? Yeah, so tangent times cotangent will be 1. Good, right? Because 1 is 1 over the other. So they're multiplicative inverses, reciprocals. So I get cotangent x minus 1, and I get plus 1. You can do it, Jeff. Minus tangent x. That looks interesting. Over 1 minus tangent x times cotangent x minus 1. All right, check me on that. Yeah, good. Okay. So the 1's go away. Is that cool?
Mm-hmm.
So I get cotangent x minus tangent x over 1 minus tangent x, cotangent x minus 1. So I know this part's good. So then what do I know has got to happen?
To the top, it's got to become 1 plus tangent x.
Yeah, so somehow this and this have to together become 1 plus tangent x, right? So what can you do from there?
Multiply the top by it? I don't know.
Oh, you surround with this.
What can you do? What can you try? I mean, obviously this doesn't go into this, right?
Take something out.
But what do you want to have left on the top?
1 plus 10.
All right, so here's what you do. You ready? You continue the idea. You ready? All right, let me put it over here so I can get more room. Here we go. You ready? So on the bottom, I've got what I want. On the top, I have this. So you guys can handle this. This is the way that I thought of doing this, but there might be other ways. That's why I wanted to see who would really try this and come up with a way that works. If I want, now watch this. I can do this. I can just do this. I can just do that as long as I do what?
To the bottom.
No. You can't add to the top and bottom of a fraction. But if I add something to this, I better at the same time
Subtract.
subtract the same thing. Freaky. Now what happens? So what's the part I want? I want this part, right? That's what I want to have. So what happens with everything else?
Cancel.
Oh, I left something out. Thank you. All right, that's still there. You guys with me? So all I did from there to there was add in what I want. So what do I get here? I get cotangent x
Minus 1.
minus 1.
Minus 2 tangent x.
Yeah, minus
2 tangent.
2 tangent x.
That's what you
You don't forget your plus. Your 1 plus.
Yeah, did I?
forgot your 1 plus tangent.
There's my 1 plus. Oh, poor little dude.
Let the cotangent x minus 1 cancel out.
Say again? No. You mean this here?
Yeah.
Definitely not. Why not?
Because you,
Says it's
the subtraction doesn't go well with.
Yeah, you can't break into a subtraction problem with division. Yeah. Oh, how did I want you to go? Let's see. Oh, there we go. Okay. 1 plus. What was? Okay.
No, just let us know.
I can do it, but a completely different one.
Oh, a completely different way.
Yes.
Okay. Okay. Something else. So what's your way?
On the original one, on the left side, could you multiply top and bottom by tangent x, which is just sine x over cosine x? And well, if you just multiply by tangent x
On which side?
on the left side,
This here. No.
both tangent x over tangent x,
Sure.
and then you distribute, and tangent x times cotangent x is 1, and then plus tangent x, and then
Oh yeah.
Oh yeah, there you go.
Bam.
That's it. Bam. I like it. Cool.
That was
Here's
so
cotangent
easy.
x by plus 1 over cotangent x minus 1. Kick ass. Alright, I know my way worked earlier, but that's way too long. So, I want you to realize something. Going into these problems, I always like to go into them. I had a certain way I tried to do it that didn't work, right? And there's always more than one way to try to do these, and most of them will work. Some of them will work quicker. Some of them will take a lot longer. I just didn't see, and it kind of depends also, it's a little bit of a luck of the draw. If you happen to see what's going to work, it's going to be a lot quicker for you. This is definitely not a problem that's generalizable. You're not going to see that a certain form tells you to multiply by just tangent or something. But here, it's because of that thing we did earlier where cotangent is the reciprocal of tangent. And that's why when you, so if you multiply by tangent, top and bottom, I like it. Then that becomes that. I love it. Cool. And it's just because they're reciprocal functions. I like that. Excellent. Sweet. So, another thing to look for generally is not inverse, but reciprocal functions of each other. Here it was nice because it was going to cancel down the 1. There, same thing, but it actually becomes exactly what I wanted to do a lot quicker. I like that. Cool. So the thing to take away from this is, when I grade these problems, I grade based on what you tried and what your reasoning behind what you tried. So very often you might have a problem like this on a test. You can imagine on a test, you got to be careful on a test. You don't want to have a lot of your time get sucked up into doing these kind of problems. So I want to see some attempts. If you get to the answer, great. If you don't get to the answer, I want to see a couple of attempts and to see where things kind of like died. And very often it's because we left a plus sign and made it a minus sign. So you're not going to lose a lot of points for that. It's the people that obviously don't know their identities, or they don't even know how to start the problem correctly, or they're doing stuff like multiplying both sides by something. It's an obvious no-no, right? Those are the people who are going to lose a lot of points. But on these problems on the test, as long as you can show me correct use of identities and a couple of attempts, because part of this whole process is getting used to being okay with making mistakes or going the wrong path or not choosing the quickest path. Just choose what you see.
So you don't want us to erase those things or screw-ups?
Yeah, I almost don't want you to, yeah. I'd rather you not, just like cross through them. So, because very often, if you don't do that, you could have been really, really close, except right there you put a 2 instead of a 1 or something, and if you would have just put a 1, it would have worked. So if you leave it for me, I can actually give you more points, and just say, hey, this is just a little typo, not a big deal. I want to try some more related to what we did last time. Like number 33 in section 7.2.
33? How big is chapter 7?
What's up?
How big is chapter 7?
How big is chapter 7? Not horribly big. Goes up to 7.5?
Okay.
Yeah. So 33. These, and when you see this, it's a lot less up in the air as to what to try. I mean, it's really a lot more obvious what they want you to do. So here there's no major question as to what to try to do on this kind of problem. What am I going to do on this problem? It's kind of staring you in the face.
Do the sine x times cosine y thing?
Good, beautiful. So you have your addition formula for sine, your subtraction formula for sine. I mean, this is almost too easy compared to the other section. The other section, it could be almost anything.
Yeah.
Right. This section, and a few of these in this section, it might not be, but most of these in this section is going to be very obvious when to apply the identities you learn in section 7.2, which is the addition and subtraction form. So for this guy, what's it become? Sine of the addition of 2?
Sine x cosine y
Plus
plus sine y cosine.
You guess? And then you got minus
Sine x cosine y
minus. Good, because sine is a nice dude, keeps the minus.
sine y cosine x.
sine y, cosine x. I like it. And then it's going to get there very quickly.
Yeah.
All right. So you see that these guys here, this and this, they combine, and this cancel. So those cancel. Sine y cosine x minus negative, so plus sine y cosine x is 2 sine y cosine x, which is the same thing as that. All right, so those would be a lot quicker. They just want you to get used to using the addition subtraction formula.
Why does that other one say negative? I mean, it's negative up top, but then the negative sign, would that be distributed in, become positive?
Of course. So this one minus that one is gone. This one minus negative, so plus that one
Oh, right. Yeah.
becomes 2 of those. Yeah. Cool.
Plus. Oh, that's right. Got it.
So here's something that trips up my calc students. Actually, way too many things trip up my calc students, but something like this. This is number 43. You guys remember doing this? Should seem a little familiar, but it's just beefed up a little bit. Now, if that tangent piece wasn't there, what way could you do this directly? Say again? Yeah, good. If that wasn't there, I could just draw the representative triangle for this and then figure out the cosine of the angle. Right? And this is one case where I definitely don't want something here. I want the cosine of these. Right, so it is the way I wrote it. It's how I intended. But how can you just distribute the cosine?
No.
I see that way too often. Well, of course you can't distribute the cosine because it's not cosine times this, it's cosine of that. But I can use cosine A minus B. So how would that get rewritten?
Cosine sine x times cos.
So cosine, cosine.
Cosine,
Remember,
cosine.
all cosine first, right?
Plus.
Cosine.
Tan inverse
Good. Plus, because it was minus.
sine
Sine.
sine inverse
That's going to be nice. Sine.
tan.
Tan inverse. Y. So you do basically have two triangles you're working with because you have two main angles. What are your two angles?
Sine and tangent.
Sine.
Yeah, inverse sine, inverse tangent. Those are your two angles you're working with. So the triangle this guy would set up would look like what? It would look like that. Yeah.
Yeah.
But which side is x? You're
A.
gonna love it. All right. Not the adjacent. No. In this case, it's inverse sine of x. So sine is x over 1. So it's got to be this is x, this is 1. You guys with me? There's our angles here, so that's going to be the sine side. To get the cosine, I just have to figure out this last side. Now it'll be square root of,
X. No, 1 minus x.
good, big dude minus the small dude, it's the other small dude, right?
Yeah.
So when you know the hypotenuse is always going to be 1, it's always going to be that squared minus
X.
the other dude squared. So what's the cosine of that angle then? No fuck.
This
Now
way.
that, there, we've done this before. The sine of an angle has to be x over 1. The sine, of course, is y over hypotenuse, and that sets up the representative triangle. Doesn't have to be a triangle that exists that does this. This is just a visual for me. So the cosine of the angle must be
Yes.
square root of 1 minus x over 1. I love it. Right? X piece over the hypotenuse.
Yeah.
That's this. Now I have to set up, now over here, look real quick. I can get that one. That one I don't even need this for. What's the sine of inverse sine? What do they do?
Cancel.
So that's just x. Great. So now I got to figure out the other triangle. What's the other triangle that I can set up?
A triangle.
So the inverse tangent of y. That means this angle has to have a tangent of y over 1. So this one's kind of nicer. Which side's y?
Sine.
Opposite.
Yeah, the y side.
Yeah.
And 1 is
And 1 is the x side. So what's that hypotenuse going to be? Y squared plus 1. So what's the cosine of that going to be?
Y squared.
No.
No,
1
over.
1 over
Y squared plus 1.
square root of y
But
squared plus 1.
don't you have to rationalize?
Yeah, you can rationalize that by multiplying top and bottom by that radical. And what about the sine in that? Sine looks a lot similar. It just has what on top?
The Y.
The y. Good. So this will be sine of that triangle will be y over the angle.
Y squared plus 1.
What's the square root of the thing? And you can rationalize that the same way. So now I have an expression for what that is more directly. Yummy. So I mean, you get at the end you get the square root of 1 minus x squared, square root of y squared plus 1, all over y squared plus 1. Is that cool? Half a hen times another half a hen makes a whole hen. Plus x, y, square root of y squared plus 1 over y squared plus 1. And you can put it all over y squared plus 1 if you want to. Cool. So we've done this kind of thing before, and it happens all the time. You must realize this if you're going into calculus, even if you're not, it's going to happen to you here. If you're going to calc and calc 2 even, this is going to happen often enough you want it to just be an automatic process. You can do bam, bam, bam. So there's a whole little section that looks like that. Yeah.
What's kind of confusing me is with the negatives. Okay, I know you took it away on the cosine one, but why did you not leave it on the tangent? On the sine?
Where are we at? Sorry.
Okay. You got your cosine of sine, the inverse sine of x, right? Then the next one, cosine of tangent.
Yes.
You got rid of the negative on that one. But
Got rid of what negative? Sorry. There's. Yeah, so
Here
that's
it's gone.
No.
Here it's gone.
No.
Is it,
All
or
right.
is it just because
All right.
of this
No.
main cosine?
So cosine of A minus B is cosine. There's no question of getting rid of it. It's defined to be the product of the cosines of each. Right? Because that's minus, it's a plus sine of each. That's the definition of the difference of angles in the cosine. So I didn't get rid of it. I used this that we proved last time. The cosine of the difference of two angles. That's what I had here. The cosine of the difference of two angles is the cosine of one, cosine of the other one, plus the sine of one, sine of the other one. That's the definition. That's how that identity works. So I didn't do anything. I didn't do anything to get rid of that minus sign or anything.
Okay, so when is it that the cosine gets rid of a negative?
Oh, I see what you mean. Okay.
That's what's confusing.
So I don't-
When does it apply? When
You
doesn't?
can't say that I have a negative in you because I don't know what that minus that is.
Okay.
But if I did have cosine of negative theta, because cosine is even, that's equal to,
Cosine of theta.
yeah.
So what if it was like negative pi, for example, cosine of negative pi? Would it still be? Then it'd be
Of course,
cosine of pi.
yeah, and you can think about it, and that's a really, it's a nice case, because cosine of negative pi has to be the same as cosine of pi, because in that case, negative pi is pi. Take that one home. So, negative pi gets you to the same place that pi does, right? They both get you to 180 degrees. They both
Okay,
get
but
you
what
over
if
there.
it was something not?
But
that
it didn't.
Like
So if you had negative...
2/3 pi, or 2 pi over 3.
Yeah, negative 2 pi over 3 versus positive 2 pi over
It
3.
gets you right, same reference angle, but
I love it. Same reference angle, and they're both negative, so they're both the same value. That's one reason, real quick reason why cosine is even. When you plug a negative value in, you get the same value you would have if you put the positive one. And again, it's more quickly seen just by my beautiful graph. Looks like an octopus. But it's even symmetry because it's symmetric through the y-axis.
okay.
Cool. But that's not coming into play over there at all. In anywhere, yeah. Alright, so last thing I want to do today, real quick. What time we got? Oh, sweet, we got time. So, let's take, for example, this guy here. put in there, what if we had the exact same angle twice over? So I didn't have A and B were different. What if they were the same? Let's say both A and B are actually...
Why is A plus B and then you put cosine B minus sine B?
Yeah.
And plus sine B?
Plus, yeah, thank you.
Let's do it.
So if these are both theta, just theta plus, so it's really what? It's really starting off as sine of 2 theta. So we're figuring out what's called the double angle formula. You can see why we call it that. So if it was sine of theta plus theta, if the inputs happen to be the same, I still have the same form. It's got to be true because the form doesn't care what these are. It would be
Sine theta.
sine theta,
Cosine
cosine theta,
Sine theta.
plus sine theta, cosine theta, which is
1,
2.
2, sine, cosine.
All right, so there is another identity that you have to know. Sine of twice theta is 2 sine theta cosine theta.
Can't you just build that though?
Vegas drive.
Yeah, okay, sure. You know it either by memorizing it or by building it up. I love it. So do the same thing for cosine 2 theta. Do the exact same thing I just did. But now figure out what cosine 2 theta would be. Question?
Something.
Nah.
Zero.
Yeah.
You said theta plus theta, right?
Yeah.
How do you fix it?
It's cosine plus cosine squared plus sine squared theta.
So how does minus that make it?
So you get
I think.
cosine theta, which is
Cosine squared.
cosine squared theta, minus sine theta.
Sine squared.
Sine squared theta.
Is this equal to anything?
0.
Definitely not.
Yeah, you're wrong.
Cosine squared plus sine squared would be 1. Cosine squared minus sine squared is I have no idea.
I have
A
no
number.
idea.
But you can simplify it in a way using what you're trying to use. So watch this. This is one representation. This has 3 different ways to represent it. And we use all 3 depending on the situation we're in. So can you rewrite cosine squared so it has sine squared in it?
Yeah.
To make them this sort of the same. Cosine squared equals what related to sine squared?
1
One
minus.
Beautiful. Cosine squared is 1 minus sine squared. So that is here. Is that cool? Cosine squared is 1 minus sine squared.
So 1 minus 2 sine squared.
So 1 minus 2 sine squared. So you can either add this, and I always just remember this, and then I can build the other 2 if I
And then you
need.
can do the opposite
Right.
with cosine.
Yeah, you do the opposite. If I would have made sine squared the same as cosine squared, of course it would be,
1 minus 2 cosine.
yeah, this would be 1 minus cosine squared. You guys cool with that piece right there?
Yeah.
Sine squared is 1 minus cosine squared, so you can always replace sine squared with that if you want to. Or the other way around.
So you get
And then I get,
2 cosine
yeah, good. Minus minus is plus, so I get 2 cosine squared.
minus 1.
I love it. So you have those 3 representations. I just remember that one, and then build these if I need them. What's really nice with that form is it's factorable, right? Because it's the difference of squares.
Yeah.
So that shows up a lot in identities, in proving identities, which you're going to be doing a lot of.
Difference is
So you
squared.
want to look for that to happen, because then you can factor it. So if I had a cosine 2 theta sitting somewhere, so if I was told to simplify this, so it would say simplify.
Would be cosine x plus sine x. No.
Yeah, if you cosine squared theta minus sine.
Yeah, cosine 2x is cosine squared x minus sine squared x.
What was it say? Then you factor it out.
And then the top is factorable, yeah. So you get c cosine x minus sine x,
Yeah. And then
cosine x
those.
plus sine x, over cosine x minus sine x, so those go away.
That's what I said. You said no.
You had a very strange way of saying
No, I
it.
just went to the end. I didn't do all that other stuff.
Well, you gotta do the middle. Yeah, that's
Why?
important. Yeah. To show people how you get to where you get.
I did it up here.
Well, it doesn't help up here. That's impressive, but it doesn't help as far as education. So that's going to happen every now and again, where you have these double angles. One way you want to go is that way. Sine twice the theta, you only have one way to rewrite it, if it helps. Let me see. The only other thing in section 7.3, which we've covertly snuck into just now,
Oh. Is the half angles?
yeah, the half angle. And real quick, if sine of 2 theta is 2 sine theta cosine theta, what is sine of 4 theta?
Force.
Oh, see now, careful. Pay attention to the form and what the form requires. That 2, why was that 2 there?
Because you added it.
Is there?
So don't overthink this. Why did I put a theta theta? Because this has got 2 thetas,
Yeah.
right? So what has this got 2 of?
2 theta.
2
2 thetas. This is twice 2 theta.
Yeah.
So it's still 2 sine 2 theta cosine 2 theta. Right? And then you can go further if you want to for each of these. Yeah, exactly. Yummy, yummy, yummy. And if I had
No.
No.
if I had sine of 3 theta, we are not. What do you think you would do with that? There's 2 things you could do with this.
2 sine of 1.5 theta.
Yeah, 3 halves theta, yeah. Or you could write this as sine of theta plus 2 theta. And then use a sine addition formula, right? And then go from there.
Or we could.
So many freaking ways, and that's one reason why students don't like trig identities, is because there are so many ways to go.
Yep.
But you just got to get used to that and accept that. All right, that's fun.
Is that 2 sine squared theta?
No.
Where we at?
The sine 4 theta?
Sine 4 theta. You can go further. There's 2 sine 2 theta.
2 sine 2 or 2 sine squared?
Yes, definitely 2. There's no reason it would be squared. So if I had sine of 2a, 2 sine a, because it's whatever I'm doubling, that's what goes here. So 4 theta, I'm doubling twice theta, so that's what goes here and there.
And then for this one, we were just doing sine squared, cosine 2 theta.
I love it. Exactly. And for the cosine 2 theta, you can break it down further. For the sine 2 theta, you get.
Or couldn't you just keep the 2? Well, the 2 theta part.
Depends on what you got to do next.
Oh, you got rid of it, but wouldn't it be the? Yeah, that's.
Yeah. Exactly. But a lot of times you want to break it down to theta by itself. Or sometimes you want to put, if I had twice sine 15 and cosine 15,
Further is what?
that would be sine of 30.
Sine 2 theta and cosine 2 theta.
And I know sine of 30, so I can do it.
Talking about breaking it out.
It's this.
So it'd be 2. You'd write this again for these. Kind of, sort of, yeah.
Yes, the mistake you can make is, this is just a form, so whatever I'm doubling is what goes here.
So you
That
have
2 has nothing to do
so
with
2 parentheses sine 2 sine theta cosine theta, and then cosine would be whatever that other one was that we just did. Yeah.
Yeah, exactly. You go further.
Yeah.
You replace that there, and you replace this with
That up there.
whichever one makes the most sense.
Oh.
So
You could. It depends on what you got to do next. And up here, we didn't have to do anything next.
so my question is actually from the
Okay. Sure.
So in web sign it has actually do verify the identity.